Okay, so this is our, how is everyone today, by the way? Good? All right, so this is our first time in lab. One notable thing you might find out is that, there's not enough chairs in here for everyone. Yeah, I know. That's, that'll be okay, because when we're in lab, I'm not going to be up here except for this time. So there's not going to be anything to listen, for me to say. And what we'll do in the future, is that we'll just overflow back there, and then all that I do is I just walk around and answer your questions. So this is inconvenient, and I'm just acknowledging it, but I can't fix it. But this is the only time that I have anything to say while we're at lab. Okay, so there's three applications that we need to use to get our job done. Okay, so would you please log into, open up a web browser and log into your GitHub account. So the way I do it is a secret, so I'm going to turn off the screen for a second. I'm all logged in there. I'll give you a minute to finish that. So remember, it's you're going to GitHub, and the way that you log in with your GitHub name, not your UTD stuff. Everybody making it? Anybody having problems?
I'm resetting my password real quick.
Huh?
I'm resetting my password real quick.
Okay, so now here's the deal. You got to listen closely to this, because this is just one of the unfortunate realities. So there's this thing called the internet. You might have heard of it. And the way it works is it's a network, and all the various computers can talk to each other with a unique name, and this name's called an IP address. Now all of these computers have an IP address. But however, unless you're on campus or connected to campus with a VPN, it's actually not possible to talk to one of these computers directly. That's because these machines have a private name that you can't talk to them directly from the wild internet. Okay, so but UTD has an IP address, and so basically what happens is that when I say, to all of y'all, I say suddenly okay, log into GitHub. More or less what that looks like to GitHub is now 50 people are all trying to log in at the same time from the same IP address. That's what it looks like to GitHub, because it all looks like it's coming from UTD's IP address, and then GitHub says, whoa, no. And so whoever logged in first, y'all won. And the rest of you have to wait about 5 minutes, which is, well, it is what it is. Okay, so now I have to fill up 5 minutes of time with jokes and stories. not really, not too bad. Okay, so while we're waiting for that, those of you who are having difficulty logging in, it's because of the it's because you didn't win the race. So now we're going to open up Matlab. Okay, so you can open up Matlab, you know, on your keyboard. If you're using Windows, you know, you've got a button that kind of looks like that. Okay, you can press it, and then it brings up the thing there, and you can type the first several letters of Matlab. You know, and it'll bring that up. Probably shouldn't click deactivate Matlab. I'm not even sure what that would mean, but maybe don't click it. So just click Matlab there. All right. So here's what Matlab looks like. This thing right here at the end of class last time, that's the prompt that we were talking about. And down here in the bottom left is Matlab's status, and it says ready, which means that it's ready. Now, when you first open Matlab, depending on how fast your computer is and whatnot, sometimes it takes a while for it to load. So there's no point in trying to do anything until down there it says ready. All right. So here at the prompt at this region right here, this is the region in which Matlab is kind of like a graphing calculator, like a plotting calculator. So if you just type like 2370, you just type it there and then you press enter. Matlab says 2370. It understands what that means. Notably, what it does is it actually says ANS equal 2370. And what that's saying is that at least on the next line, you can type ANS, and Matlab will interpret that as 2370. So if we type ANS again here, it says, okay, 2370. And then you might wonder, like, what if you type 2 times ANS? What will that do? Well, at the present time, ANS is 2370. So it seems reasonable to suspect that twice 2370 is what it'll write. Okay. Okay, great. So now, if I type 2 times ANS again, what will it say? Will it say 4740 again? Nah, in fact, because at the present time ANS is 4740. Okay, so if we do it again, interesting. All right, then you might like get curious, like, well, what all does Matlab know about? So you could type meow. Okay, maybe Matlab knows what that means. You press enter and Matlab says undefined function or variable meow. All right, so in fact Matlab is not it doesn't know what you mean by meow. All right, so then if we wanted to be specific about what we meant by meow, you could type meow and then equal 2018 or whatever you like, and then Matlab responds with okay. And what that means is that you're essentially telling Matlab, from now on, when I say meow, I want you to understand that to mean 2018. Okay, so now if I type meow again, then how will Matlab respond? Yeah, it says 2018. Because what Matlab does is it looks at that and says, now, do I intrinsically know what meow is? No, I don't intrinsically know what meow is. In the same kind of way, that Matlab intrinsically knows what you mean by 2370. It means that number. But when you type meow, in principle, that could be anything. So when you type meow, okay, Matlab asks itself, do I intrinsically know what that means? No. Was that one of the things you told me I need to remember? In this case, the answer was yes, and Matlab does a lookup and says, ah, yeah, you told me it was 2018. All right. So far, so good. So if you type, say 23 plus 70, okay, then you know, Matlab intrinsically knows what 23 is, and it intrinsically knows what plus is, and it intrinsically knows what 70 is. You don't need to inform it about these things. So what is your suspicion about how Matlab will respond? Anyone care to speculate? Yeah, it's going to take 23 and 70 and add them, you know, just like you would on pencil and paper. Get 93, and so is the only thing it's going to say is just 93? No, it's going to say A and S equal 93. That's because every time Matlab evaluates something, if, so like here's this says meow is 201, meow equal 2018. So Matlab evaluates 2018 and interprets it to mean that number. And because there's a left-hand side, it says, oh, and you want me to store that value inside of the name meow. Whereas when Matlab will evaluate this, and it evaluates to 93, there's no surprise there. But because there's no left-hand side to this evaluation, it stores it in the default location, whose name is ANS. So basically, every time you evaluate something, if there's not a left-hand side, it gets stored in the name ANS. So you know, if I type 6, then now ANS is 6, and now I'm going to evaluate this again, but I'm going to store it under a name. That way, we can refer to it later. Now, when you're dealing with this command line, with this thing here, okay. So now I've been watching the clock. It's been 5 minutes. So those of you that didn't win the race, would you please try again to log in? Did everybody get there? Is anybody still not succeeding? Everybody's logged in? Yeah? All right. So now when you get to github.com there, for reasons that, you know, I mean, who knows why, there's this symbol here, and where GitHub is concerned, they consider that to be they consider that to be a cross between an octopus and a cat. Okay? I'm not saying that I do, I'm just saying that they do. And it's called the OctoCat. So would you please click on it? Okay, so that just makes sure that you're at the right place. So now you should have a repository somewhere. I don't know what your screen will look like. Like maybe you see, do you see one that looks like that somewhere? Okay, would you click on yours, please? So everybody's repository has a name that looks like 18F-math-2370-Q and then a bunch of letters and numbers. Okay, but mine is special, and mine is called key. You know that then looking at that. You know, I browsed to that thing, and what that is that I actually, besides all of y'all's repos, I have two repos. I have one where this little suffix is dev. That's where I make new ones, new exercises for y'all, and then key is where I pretend that I'm a student, and then I answer the questions myself and make sure that the whole system is working. You know, and you might be like led to believe like, oh yeah, I'm gonna write that down, and then I'm gonna go to that one, right? If that's where the answer is. Okay, of course you can't reach that, right? It's a private repository, okay? And similarly, your repository is accessible only to you, and not everyone else. Good, but at any rate, your repo will look like this. Repo being short for repository, where all your files are. So now GitHub, its entire existence and purpose is just the management of files. It doesn't care very much, and definitely not specifically, for Matlab. Okay, it's just its whole existence is just to manage files and different versions of files and things like that. Okay, so you know, you will have a folder named plus pex. So it's the first character name is plus, and then you'll have another one named pex. All right, so I'm going to look at plus pex real quick. So what plus pex is that you know, there's two aspects to grading y'all's programming assignments. One of them is like a purely mechanical thing, where I'm just checking the program that you wrote. If I give it this input, does it generate the correct output? Okay. The way I do that is with all the programs that are in this plus pex directory. So essentially, you can kind of think of the plus pex directory as like my directory. Yeah. But it's not. There's nothing in there that's a secret. By all means, look at it. You know, if you just like, you know, have the urge to just see what's in there. But more or less, what those are is that those are programs that run your programs to see whether or not your programs are generating the correct output. So you know, if you just had a mind to look, you know, you could just click on one of them and just look at it and say, oh yeah, there's a thing. Okay, but it's not really so interesting to y'all, perhaps. The thing. So now I went back. You know, I clicked back a couple times and now I'm here again. So the place that's for y'all, the place where you're gonna find your programming assignments, and the place where you're gonna put files and that kind of thing is this one. Not the one with plus in its name, but this one. Okay. So now there are 3 assignments currently: 000, 001, and LIB. So if this is your first time, writing any programs of any kind, you should know the convention is that LIB is short for library, and conceptually what it is like a place to put a lot of miscellaneous things that are useful to you. I'll say it like that. So we're not going to deal with 000 or 001 today. We're just going to deal with LIB today. So would you please click on LIB? Okay. So you can see that there's some interesting stuff in there. Your repo at the current time probably doesn't have the is in and whatever, and that's normal. Okay. Any questions so far? All right. So now we have to do another race. So we're going to start another program now. So would you please, click the Windows button and bring that thing up there? Okay, and then would you please type GIT, the first 3 letters of GitHub, and then click on that one, not the one that says shell, but the other one. Okay, so it brings up an application that looks like this. So I'm going to make it full screen there. So now, what this application is it makes it easy to copy the files, the remote files. So these files that you're looking at in the web browser, those are remote files. Those are stored somewhere out in the wild internet. Okay, who knows where? And besides that, it doesn't matter exactly where. But these are stored out on the internet. Now, to perform any work, you need to get copies of those files on these computers, on your laptop or one of these lab computers. Some way, somehow, you need to get copies of all these files on that computer. All right. This application is called Github Desktop, and that's its purpose in life, is to do that. So now, concerning this application, the way it's like intended to be used is that you would install it on a machine that like you're in control of, like your own laptop or whatever, and then you log into GitHub using it in this application, and then you basically only have to do that once. You just log into GitHub just once. But here's the deal. is that these public lab computers, every time you log off, it destroys your the state of the computer. What I mean is that it like forgets everything that you did essentially, and that's good. That's a security feature. But what that also means is that if you're not using your laptop, if you're using one of these public computers, every time you turn on GitHub Desktop, you've got to log in. And what that means is that now we're all going to log in, and there's going to be another race to see who wins, and see who gets left out and has to wait 5 minutes to log in again. So here we go. Oh yeah, I've got to show you how to do it. I guess I could just do it real quick and make sure I win. Okay, but it doesn't matter. So in the top right, there's a gear there. So if you'll click on the gear and then select options. Okay, and then right there it says add account. So you click on that. If this were your laptop, you'd just do this once. But if you're going to use the public computers, then you're going to have to do this every time. See who wins. Ah, I was a winner. Okay, were there any losers? I don't mean that like, you know, like I'm not. I just mean did anyone type in your correct password and it says no, I'm not going to do it. Everyone got in? You didn't. Yours didn't make it. Okay. So it's 58. All right. I gotta watch the clock. So now I've got to fill 5 more minutes, but that's okay. We've got plenty to talk about. So now I'm going to go back to Matlab there. Okay. And to remind you what we were talking about is that I had typed this. I had typed 23 plus 70, and without any of your without anything from you, Matlab is able to intrinsically understand 23 and plus and 70. It intrinsically knows what those mean. So if you type that, Matlab says, ah yeah, you mean that evaluates to 93. And because there was no left-hand side to this evaluation, that means that Matlab stored the result of that evaluation in the default location whose name is ANS. Now, perhaps 23 plus 70 is like really important to you, and you want to remember it forever. So the way that you can do that is you come up with some name for the left-hand side. So I'll write like woof, woof, and then equal 23 plus 70. Okay, so now that's nice. 23 plus 70. What MATLAB's going to do here is that first it reads woof, and then it reads the equal, and then it says, oh, I get it. You want me to evaluate the right-hand side of this thing, and then take that, whatever that evaluates to, and store it in the name woof. Whoops. There. I don't know what I did. I did something weird I did something weird right here. I didn't really see it. But okay. So you type this, and MATLAB says, okay, I got it now. Woof is 93. All right. So, you could also do something like this. You could say meow plus, I don't know, 8. So something like that. And all right. So the way MATLAB considers this is it in the first place, for this evaluation, is there a left-hand side? For the one that I've currently typed there. There's not a left-hand side, right? So that means that if MATLAB is able to successfully evaluate meow plus 8, where will it store the value of the evaluation? In ANS, because there's no left-hand side. All right. So MATLAB looks at this and says, okay, meow plus 8. Now, I intrinsically know what plus is and what 8 is, but I don't intrinsically know what meow is. So MATLAB says, well, maybe meow was one of those things that they told me to remember. So MATLAB does a lookup, and you can see it right here, the things that you told MATLAB, right? right there. That's the name of something that you told it, and its value is currently 2018. All right. So what Matlab does is it takes this right here, this meow, and says, nah, I didn't intrinsically know what meow was, but that's one of the things you told me to remember. So it replaces that meow with a 2018, and then evaluates the expression, and you get what? 2026. And then because there was not a left-hand side, it stores that value in ANS. Any questions so far? All right. So you could type something like 20 plus 18 plus, say, like hippo, I guess. And now that's what what Matlab does when it looks at that. Again, it says I intrinsically know what 20 is, what plus is, what 18 is, what plus is. I know what all those things mean. I don't intrinsically know what hippo means. So then I'm going to perform a lookup and see, is hippo one of the things that you told me to remember? Well, is it? It is not, because you can see that hippo is not in this list over here. Not over there. So, notwithstanding, if I go ahead and press enter, what will Matlab say? Yeah, it's going to say, I don't know what you mean by hippo. Any questions so far? All right. But we could give a value to hippo, and then we could do it again. So let's do that. Suppose I say hippo equal 9. Okay, so Matlab says got it. Hippo's 9. Now suppose we want to evaluate that thing again. Maybe you just forgot to say, oh, I forgot to mention that hippo was 9, and you want to run this again. So on the one hand, you could just type it again. That'd be fine. But when you're using tools like this, it's good to know that you don't really always have to retype everything, because Matlab remembers everything you typed. So right here, with nothing on the command line, if you just press the up arrow on the keyboard, just press up. Then you can start scrolling through all the various nonsense we've typed for Matlab, right? There it all is. And I'll just go to that. I'll go to that one right there. That 20 plus 18 plus hippo. That the first time that we evaluated that, hippo didn't have a value. So there it is again. I don't have to type again. And terrific. Any questions so far? Okay, it's been 5 minutes. Would you please try logging in to GitHub Desktop if you weren't able to get it the first time? Okay, is everybody in? Got this good to go? All right. So now you can see it's kind of like summoning you to press that button up there. It's kind of blinky. Okay, so let's click it, and then you're given these options: add, create, and clone. So add is if you wanted to make an entirely new. No, add is what? Let me think about that. I'm not real sure what add means. Well, it would mean that you have a repository, but it's not your repository, and you want to like take charge of it, kind of. Create is that you want to make an entirely new repository, but clone means that there's a repository out on the internet, and you want to copy it, and you're part of that repository. So what we want to do is clone. So you click clone there, and there should just be one repository that shows up. But mine's going to show like 10 million repositories because I do this a lot. So you should just have one, and it should be that same name, 18F blah blah blah. Okay, so please besides this thing that I'm typing here, you shouldn't have to type anything. It should look like that for you, except it should say Q whatever. Okay, so select the one for you there, and then click clone. So you clone it there, and then I suggest you just accept the default location for where it's going to put it, and you click OK. So what it's doing now is it's copying files from the remote server and making a local copy on the computer that you're sitting at. All right. So again, Git and GitHub, their entire existence and purpose is just the copying files back and forth, and they don't have anything specific to do with Matlab. So for now, I'm going to just minimize this because we're done with GitHub for the moment. So any question about that? We're okay so far? So I'm going to minimize that, and now I'm going to close Matlab and then reopen it. And I've got a good reason to do it, I promise. Okay, so we're going to close that, and then I'll minimize the web browser there. Okay, so clicking clone in GitHub Desktop, what it did is that it made a folder named GitHub on the desktop. Amazing. So if you click it there, you'll see your repo. Okay, so if you would, click there. Okay, so here's those same files we were looking at on the web browser. There they are. Okay. So now, what I'd like for you to do is see there's a file called startup there, and so before you do it, because I heard many of you already do it, is that I know that it's I know that in Windows, like the thing that you do is you like double click stuff, but you gotta not do that. Unfortunately, so if you already double clicked it, Matlab is starting, go ahead and wait for it to finish starting and then close it again. And I'll give you just a second to do that. All right, so instead of double clicking, right click on it and then go to open with and select Matlab. Now, double clicking on something and doing the right click open with Matlab, you might reasonably think that those are identical, but for reasons I don't understand, because I don't use Windows except for when I'm in this room, those are not the same thing. Okay, so I'm telling you something important, specifically that by the end of this class, and definitely next Tuesday, someone's going to be in here and say, it's not working, and then the reason why it's not working is because you didn't do it this way. Okay, so it's coming up there. All right. So now, the same files, and we've got them open in Matlab. All right. So what we're going to do is we're going to work on the assignment called lib, L-I-B. So the way to do it is that up here, where it says blah, 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 and then your repo name, there's a little right arrow. So if you would, click on the right arrow. And then, it tells you the two folders there, plus PEX and PEX. So please click on PEX. And then we're going to do that one more time. Now there's three folders, 000, 001, and LIB. Please click on LIB. And then there we are. Okay. Any questions so far? All right. So now, momentarily, we're going to go back to the web browser, because the web browser is where you read what it is that you're supposed to do. Okay. Matlab is where you do it, and then GitHub Desktop is where you copy files back and forth. So three different things. The web browser tells you what to do. So let's go to the web browser. Okay, and here we are in that same location. Your repo, PEX, and then lib. And again, you probably won't have all those files, but that's okay because you've got to make them. All right. Good. So if you scroll down, there's some information, and and you should read that information. Okay, but I'm not going to sit here and read it to you. So you read this information. It helps you understand what it is you're supposed to do. But at any rate, at the bottom of each assignment that you're supposed to do is something that looks just like this. It says task. These are the things you're supposed to do. So at the present time, lib has 5 things you're supposed to do: is in, is are, is z, is even, is odd. Okay, so we've got to do those things. Now, to find out what those things mean, you can click on them. So I'm just going to click on is in. All right. So that takes us to there. Now, to understand what you're supposed to do, you got to scroll down a little bit. Okay. So this is a description of is in. It's a function. And what it's supposed to do is that you give it an input, and you give the function an input, and what it does is it confirms or denies whether or not that input is a natural. That is to say, a natural number. So, you'll know that you have this function right when you could do something like, you could say is in, and then you could give it like, the number 2370, and it should say yes. That is a natural. You should also be able to give it, for example, the number 2370.8, and it should say no, that's not a natural. Right, so does everybody understand the idea? But it has to work for anything at all, which means that if you call is in with like a giraffe, it should say it should work, but it should say no, a giraffe is not natural. Right? It shouldn't like just blow up. Okay. Good. So if you scroll down a little bit, or just look down, I guess. Here's some requirements about how it's supposed to work. Okay. And notably, this line here says that is in, this function you're supposed to write, must call this other function called is z. And if you remember correctly, is z was one of the things that's on the list of things you're supposed to do. So if is in means is a function that confirms or denies whether or not something is a natural, do you have any speculation about what is z might be? Yeah, is an integer. All right. So what that means basically is that, oh yeah, is in, actually we're not supposed to start with that one, because we've got to finish is z before we can do is in, right? Okay, so let's go back. Can't do is in yet, so because it says is z. So we can click on it and then scroll down to its description, and then, oh, what a surprise. This is a function that's supposed to figure out whether or not x is an integer. All right. So we can figure out if x is an integer. And then again, if you scroll down or just look down or whatever, notice that this one says that this function has to call is r. All right. So is r. Any speculation as to what that might mean? A real? Okay. So that's also one of the ones we're supposed to write. So let's go back to is r there. And then, yep, determines if x is real. Okay. Let's scroll down a little bit, and then oh look. So I guess we reached the end of the rabbit hole, right? So finally we found the one that we're supposed to do first, because this one's not supposed to call any other things. So is real, is r, is a function that should say should say yes or no to any input that you give, whether or not it's a and that yes or no means it is a real number or it is not. Okay. Everybody understand the idea? So now we can go back to Matlab. Okay. And y'all don't have these files, so I'm just going to delete these. Well, y'all don't have to do this. I'm just getting these out of the way. Yes. Yes. Okay. So what we want to do is we want to make that function is r. Okay. So let's do it. So right here you can click in the top left there. There's a thing that says new, and it's a big plus. So new function. So that's what we're going to do there. And there it is. Now this first line where it says function and all that stuff. Function is a special word to Matlab, and basically you can understand that to mean that while it's perfectly okay for you to make for you to say down here, like it's fine for you to say meow equal 2018. Matlab says, okay, I got it, no problem. That's because meow is not like intrinsic; it's not important to Matlab. You know, if you just like to know the technical jargon for it, that means that meow is not a reserved word. But function is a reserved word, which means that if you come down here and type function equal, 7, Matlab's going to say, you can't use that word, that's my word. Function, that's mine. All right. You can always tell what Matlab considers to be a reserved word because it'll highlight it in blue. Now, like when you're writing math on the page, like you're doing your math exercises, not with Matlab, but just like in all your other math classes. You know how parentheses need to be paired up? Like if you have an open parentheses, you need to have a closed parentheses. And if you have an open brace, you need to have a closed brace, that kind of thing. So this word function signifies that we are beginning the definition of a function. And that's like an open parentheses. And you have to have a closed parentheses, which basically means like, and now we are finished talking about this function. This end word, the word end there, that's like the closed parentheses. That's what it is. Okay. So everything between function and end is the definition of the function. All right. Now this part right here that I've highlighted, which is to say everything on that line after the word function, that's called the signature, the function signature. So we need to look up what's the signature of the function. By the way, what's the name of the function we're trying to do? Is-R, right? So let's go back to the thing there, to the web page, and it says, okay, for the function is-R, its signature is supposed to be thus. Okay, that thing right there. So I'll copy it, as in Control C or right-click copy or what have you, and then right here I'm just going to paste. There it is. So now the signature is right. Any questions so far? So y equal is-R of x. Yes? Right. Correct. And after that, the top line of this function file that we just made should say function space y space equal space is-R blah blah like that. Okay. So this green stuff right here, we'll deal with that a little later. For now, I'm just going to delete it, so it's gone. Okay. So now we've got a file that looks like that. So now I'm going to just type save there. Okay. Well, I guess I didn't type save. What I did is I typed Control S. But you could probably also click save. Yeah, that works too. Okay, and you need to name it is-R. Just like it says there. Okay. I'll give you a second to catch that. Okay. So now, this function, it's got this equals here, and then we've got stuff on the left of the equal and stuff on the right of the equal. So this first word, that's the name of the function, and then all the stuff in parentheses are the inputs. So the way that you say this is that this function has a single input argument whose name is x. And the stuff on the left-hand side those are called the outputs. And this function has a single output argument named y. So what you need to do in between function and end is you've got to say what y is somehow. Y has got to be given a value. So what I'm going to do is I'm going to type y equal 2370 and then a semicolon. Okay, then I'm gonna click save there. All right. So y equal 2370. So now at the console down here, you can type is r, and then now I'm going to give it a number like 4. Now our intention is that this function, when you give it a 4, it should respond with basically saying yes or no as to whether 4 is a real number. So is it? Is 4 a real number? Sure it is, right? But how's this function going to respond?
It's going to equal 2370.
It's going to say 2370. Okay. Then we could ask, what about like kitty? So like if you just type kitty at the console like that, of course Matlab's going to say you didn't tell me what kitty means. But sometimes you want to like refer to kitty or whatever, and you don't want it to be a variable name. You just want to like talk about the word kitty. So if that's your intention, then you can type a single tick, which is not the double quote, but it's the same button where you can hit shift that button and get a double quote. So it's right next to the enter key. So you can type a single tick, and then kitty, like so, and then Matlab says, okay, yeah, I understand the word kitty. So we could ask, is r kitty? So the answer to this question surely is no, right? But how is r going to respond? It's going to respond with 2370, right? Okay. So can you see like mechanically how this function is working? Yet its current behavior is nonsense. It's not what we need it to be. Yeah. So there's two answers to that. So you're asking about these 4 spaces I put there. So are those 4 spaces required? Where Matlab is concerned, syntactically they are not required. Where this class is concerned, they are required. So like when you I don't want to get into it too much because we don't have enough context to get into it. But just like your math instructors encourage you, you need to write your responses like in an organized way and not sloppy, and all that, because there's like a certain style to write the answers to your math exercises. In the same kind of way, there's a certain kind of style that is expected when you're writing programs. And these programs are so small that it doesn't really, this is not really the place for me to talk about the style, but I promise we'll get into it. At any rate, part of the aspect of good style is having that Y all the way to the left like that. That's bad style. And then moving it over one position like that, indenting it is good style. And in the end, the reason why is because this statement is part of what the function does. So you indent it so that you know that it's inside of the function, essentially. All right. So now, isR is supposed to. Are we almost out of time? When does this class end? No, 45, right? Okay, good. We still have plenty of time. What was I saying? Oh yeah, I said isR is supposed to say yes or no as to whether or not the input is a real number. Okay. So in MATLAB, the shortcut to yes, the name for yes is true. So you could type true at the console there, and it responds with this sort of curious thing there. it says logical 1. That's curious. So if true is how you say yes in Matlab, then how do you say no?
False.
False. Ah, okay. And now it says logical 0. That's interesting. So, well, at any rate, you know, you might have heard, you know, surely that computers reckon everything with zeros and ones, right? That's because they count in base 2. And more or less, there's a long-standing convention in computer science that essentially 0 means false, and non-zero, meaning 1, means true. Okay. Now, logical, what that means is that the word logical, that means it's a kind of thing, in the same kind of sense that a number is a kind of thing, and a function in math is a different kind of thing. These are two different kinds. Logical is a kind. To say it in a computer science way is to say it's a type. So logical is a type of thing, and it's not the same as a number. Nevertheless, they're represented with 0 and 1. Okay, so now if we type 23 plus 70, again, and we've already done that once. If you type 23 plus 70, then what Matlab understands that to mean is that, oh, 23 is a number, 70 is a number, and what you're saying is you want to make a combination of these two numbers, and the combination you want to make is plus, to add them. So numbers have the property that you can take two of them, combine them with plus, and get another number. What's another thing you could do with numbers besides add them? You could compare them, but I want to have something that that gives you a new number. You could multiply them, right? So how do you write multiply in Matlab? Asterisk, right? Shift 8. So you could multiply them. Oh, incredible. Okay, so now you might ask, like, well, logicals, like false. They're not numbers. Because they're not numbers, you can't add them. Okay? Just like you can't add, you know, cats. Okay? They're not numbers. Nevertheless, you can take logical values and you can make combinations of them in the same kind of sense as add and multiply for numbers. But the combinations are different. The math names for the combinations are, among the possibilities are conjunction and disjunction, which are fancy names for and or. All right. So now, one of the things we talked about on Thursday is that in math, the equal sign in math, like on the page, like when you're writing with your hand, the equal sign does double duty. In some circumstances, equal means assignment. Like on a math page or in a textbook, you might read something like "let x equal 5," and what that is interpreted to mean is that from now on, when I say x, you are to understand that I mean 5. But you know, later or on a different page or what have you, you could say, you know, something like if x equal 5. Now you're not assigning x's value, rather you want to know, is it the case that the value of x is equivalent to 5? So these two different notions, assignment and test for equivalency, they're written the same way on the page in math. I really wish it wasn't the case, but it is. In computer science, they're different, and in programming they're different. So like when you type meow equal 2018, what that's saying is that I want you to evaluate the right-hand side, and then I want you to take that value and store it in the name meow. And Matlab says, okay, right? No judgment, I'll do it. A separate question would be, you know, if we made a bunch of computations, we might wonder, is meow still equal to 2018? And that's the question. So the way that you ask that question of Matlab is that instead of writing a single equal, you write two of them. So you write equal and then another equal. Now, you know, you could press enter, but I want to explain what it's going to do first. what MATLAB is going to do is that it reads this and says, okay, meow. Now, I don't intrinsically know what meow means, but I do know what equal equal means. That's the test for equivalency, and I do know what 2018 is. So MATLAB does a lookup. Is meow one of those things you told me to remember? Yes, it is one of those things you told me to remember. It's right there. So what MATLAB does in response to that is you're essentially asking the question, is 2018 equivalent to 2018? So, you know, in human language you would say, yes, right? And then, you know, what MATLAB is going to respond with is what? It's going to say logical 1. And remember that that means true. So, yes, in fact, it is the case that meow, the present value, the current value of meow is equivalent to 2018. So now I'm going to press up so that I can consider that line again. And I'm going to change it to 2019. And of course this means exactly what you think it means. And now we're asking, is it the case that 2018 is equivalent to 2019? Of course, in human speak, the answer is no. And then MATLAB makes its considerations and says no. Okay. Any questions so far? Now, here's a separate matter. Is that you know, concerning these logical values, we want to be able to combine them with, like, you know, like adds and multiplies and things like that. But for logical values, the names are conjunction and disjunction, among some other possibilities, and those mean and or. So here's an example of a statement that could be true or false. So it is currently daytime. True or false? It's true, right? Here's a different statement. There is a panda in this room. False, right? Okay. Unless I'm, like, severely mistaken. So one of those is true and one of them is false. So concerning those two statements, we could combine them with the word and. Now I could make a compound statement. I could say, it is currently daytime and there is a panda in this room. So the overall statement is false. One of the things is true, the first thing, but the overall thing is false. Because and means that we need both of them to be true in order for the compound statement to be true. So in MATLAB, the way that you can make such a compound statement is here's an example. We could say, okay, how about this one, 2370 equivalent, and now I'm going to type something that may give you a moment's pause. How about 2370.0? Ah. So if you've never done any programming before, you're probably thinking, yes, of course. If you have done some programming before, you're thinking, I'm not sure. Whether or not that's going to, you know, who knows. But at any rate, you know, one of the convenient things about programs is that, and MATLAB in particular, is that if you ever have a question, if you're not sure, just type it, you know. MATLAB doesn't care. It's just waiting for you to say the next thing. Okay, so then, all right, MATLAB says that that's true. All right. Then now I'm just going to do some spaces there and ignore this stuff on the left for a second. And I'm going to type another statement that is false. So, like, how about 4 equivalent 7? Okay, so that's false. And each one of those, you know, conceptually, you could evaluate just that part or just that part. Okay, this thing on the left, that's going to be true because we just evaluated and it was true, and this thing on the right, that's going to be false. And what we want to do is I want to say, like, and, you know, like the word and. So the question is that you know, you write the plus symbol to mean plus to MATLAB. How do you write and into MATLAB? Yeah, is that on your keyboard is a symbol named ampersand, and it's Shift 7. And you've got to write 2 of them. So ampersand, ampersand. Now the reason why it's called ampersand, by the way, if you know, unless I've, you know, have been misled, is that when you say the alphabet, one of the letters considered to be in the alphabet is the ampersand symbol, and ampersand stands for and per se, and, because if you're trying to say it, it's kind of confusing. Ampersand, whatever, it doesn't matter. So what we want to do is combine these two statements. But PEMDAS, the order of operations. It tells you that you've got to do like multiplies first, multiplies before adds. Just like that. For all things, including all the stuff that we've typed here, there's an order of operations. And what I want you to observe is that here's an operation, test for equivalence. Here's an operation, and here's an operation, another test for equivalence. So there's 3 of them. And it's not clear which one MATLAB considers to need to happen first, right? So we could do an experiment to sort of see which one MATLAB thinks should come first. But at any rate, if I write any string of arithmetic, numbers and adds and multiplies and what have you, how can you make sure that, for example, that add occurs before that multiply? Parentheses, right? That's the P in PEMDAS. So please write some parentheses to make sure that the tests for equivalency occur first, before the and. So what do you need to do? For example, you could do this, right? Like that. Okay, and then I'll put them around the other one too. Okay, so now that we've done those parentheses, MATLAB will definitely perform the equivalency tests before the and. Okay, so now, essentially this is saying true and false. So what's going to be the answer? False. Right? Just like me saying, it is currently daytime. That's true. And there is a panda in this room. That's false. Okay. Fine. So we also want to be able to say or. We want to be able to say or. Now you need to understand the following kind of thing about mathematicians and computer scientists, and especially like programming languages. Or, in those contexts, which is to say disjunction, means something different than what is typically meant on the street in English when you say or. It means something slightly different. Specifically, well, I'll give it to you with an example. So like I'm a mathematician, and nevertheless I have children. Okay, and I'm a mathematician here, and more or less a mathematician at home. So they're like quirky. Because I'm a little quirky. So when we go meet people, like say we go to a restaurant, and if the wait staff says something like, they want to get a dessert, and then the wait staff says, "Would you like cake or ice cream?" My children respond, "Yes." Okay, and then of course that's not at all what that person meant, right? They meant that you are to select one choice from the following list. Right? That's what was meant. But all right. So when you mean exactly one of these, there's a different technical word for that, and that's called exclusive or. So right now I'm talking about or. the or that says cake or ice cream, and then you say yes. Okay, so if and is ampersand ampersand, like so, how do we say or? Okay, so then it's 2 vertical bars. Another name for those bars is pipe. So that's shift and then the character that's above the enter. So now this is saying true or false. What's going to be the response? True. Going to be true. Yes. Cake or ice cream? Yes. Okay, good. Now finally we can get to the business of this is our thing, because you might remember that we were talking about that function. Okay, So MATLAB has lots of built-in functions, and one of them is a function whose name is isNumeric, which is to say the letters is, and then numeric. So, we could type isNumeric, and then, like 5. So what do you suspect about MATLAB? How's it going to respond? It says true. MATLAB says yes. Then we could type isNumeric. How about kitty, where we're putting it, we're considering the word kitty, so it's in single quotes there. So how's MATLAB going to respond? And it says, nah, kitty, that word is not numeric. All right. So probably a good idea to edit isR is to do what? Right. How about the name of the input is x, so part of a good idea might be to change that 2370 to isNumeric x, right? That's a good idea. Wow. And then you can save that now. So save it. And that means that at the console now we can type isR, and then 5. And how will MATLAB respond now? It says yes. And you could get you give it giraffe. Are there 2 F's? I don't even know. So you type enter, and MATLAB says no. So you might think, well, why are we even writing this isR function if isNumeric is already there? That it seems like it just about does the job. Okay. Well, here's the deal: is that the prerequisite for this class is only pre-calculus, so I can't assume you know a lot. But there's a thing in math called a vector, which is where you can consider it like a list of numbers. So if this list happens to have one item in it, just one, like a list with just one thing on it, such a thing is called a scalar. But we could make a list of numbers, say like 23,70, like that. And what that is this kind of thing is called a vector. It's got 2 components, the first and second. So it's like a list with 2 items in it. Now, what will isNumeric say about this? isNumeric is going to say yes. So right. So isR, the meaning of isR is that it's supposed to only say yes when this is a point on the number line. Meaning like for just 23, that'd be fine. For just 70, that'd be fine. But for the vector 23,70, no. The answer should be no. So this thing here, it's numeric, but it's not a scalar. So if the built-in function in MATLAB to test if something is numeric is called isNumeric. Is-scalar. So we could type is-scalar of 5 there. Oh, that works. What about is-scalar of 23,70? Like that. What's it going to say? It's say nope. Now here's a surprising thing is that if you take the word kitty, I know we're just about out of time. I've got about 60 seconds. If you type the word kitty, it's going to say no. Is-scalar will say no. But now here's something surprising. What if we take the kitty and then we delete the itty, so that it's just a K there? So now it's a word with 1 letter in it. Just 1. Now now the answer is yes again. Okay, so is-scalar cannot be isR all by itself either. So in a sense, isR needs to be somehow something about is-numeric and something about is-scalar. What's it supposed to be? Is-numeric and is-scalar. Okay, so I leave that to you, and this is the last thing I have to say. So suppose that you edit this file and you get to a stopping place or what have you. So I've saved it. Okay, now you come back to the AutoCAD down here, GitHub, and you open up this thing again. Okay, history, that's where you can read like, different changes that you made or I made. If you click here on changes, well, I deleted all those files, so all those files changed. But if you're looking at yours, you'll probably just see one there, like, oh, you just did some is-are stuff. Okay, so now you can click here on the summary and say, this is a message to you, so you can remember what it was that you did. You can say, whatever, to help you remember what it was that you did. And then you can click commit. So what that means is that on that computer that you're sitting in front of, those changes that you just made are now considered permanent changes. But not out on the wild internet, the place where I can reach. So to say, these changes now need to be permanent out in the internet, in the top right you click sync. And now, once you've done that, and I go back to my office, I can see your changes and grade your work. Have a nice Tuesday.
Oh.